Example number 1. Use the bisection method to find the solution of fx is equal to x cube minus 7x squared plus 14x minus 6 on closed interval 0 and 1 accurate to within 0.01. So you know that in solving this problem we have to check the sign of the function values at x equal to 0 and x equal to 1. So for the x equal to 1, f1 have positive 2 and for the x equal to 0, f0 have minus 6. Therefore, for the function value have opposite sign. Therefore, we can continue the process of the finding root by using the bisection method. So, firstly we have to find the midpoint between 0 and 1. It is 0.5 and the sign of the x equal to 0.5 it is minus 0.625. Therefore, when x equal to 0.5, we have negative sign for the f.5. Therefore, our root is between 0.5 and 1 because x equal to 1, f1 have positive sign. Then again we have to find the midpoint between 0.5 and 1. It is positive 0.75 and the sign of the f.75 are positive sign. Therefore, our root is between 0.5 and 0.75. Therefore, now you know what is the process finding the root by using the bisection method. So let's see the create a table and using the scientific calculator, we can easily find the old roots quickly. When using the calculator, firstly we have to create a table. In the table, n is the iteration, a and b are our input values, p is our midpoint, p is equal to a plus b over 2, p represents the function value at the midpoints. So to create a function in the calculator, I use the letters R on the calculators. Therefore, simple a and b represent the capital A and capital B. Also capital P represent the capital C and FP represented by the capital F. Therefore, firstly we have to create this equation by using the input values a and b. So I write here capital C is equal to, in the brackets, a plus b, capital A plus capital B over 2. To continue next step, I use the colon mark. And again, I type the function by using c instead of x. So, capital C cube minus 7c squared plus 14c minus 6. This is our function and finally click the calc button. Now we need to enter the values for the capital A. Capital A is equal to 0. Click the equal button. So capital B, we need to enter the value 1. And again we have to click the equal button. So we have 0.5 for the C and we need to type here 0.5. Next again click the equal button. We have minus 0.625 minus 0.625. Now again click the equal button. Then we have negative sign for the p is equal to 0.5. So in the second iteration, a is equal to 0.5. Also, we don't need to type here 0.5. We can enter the capital C here and click the equal button, and b is equal to 1. Here is not change. Therefore, I equal to 1, and when click the equal button, we have 0.75, and again we have positive value 0.984375. Here we have positive sign. Therefore, b is equal to 0.75. It means our root is between, in the third iteration, our root is between 0.5 and 0.75. again click the equal button, and we have 0.5. It doesn't need to change, and again equal button, and we have b is equal to 1. We need to change it, therefore I click the alpha, then C, then I equal button, and we have 0.625, and again equal button, we have 0.259765625, again equal button. Here we have positive sign, positive value, therefore our root is between, in the fourth iteration our root is between 0.5 and 0.625, therefore we don't need to change the value A, and equal button, and we need to change here, therefore I click the alpha and C, and equal button, we have 0.5625, again equal button, we have here negative value 0.1618652344, again equal button, and here we need to change the value of A, because here we have negative sign for the FP, therefore we need to enter this value for the A, therefore I here click alpha and C, and equal button. In here we don't need to change the value of B, equal button, therefore we have this value. The 5th iteration, in the iteration 5 we have 0.5625, and here you need to change 6 to 5, and our value is 0.59375, and again equal button, then we have positive value 0.0540466386. Here we have positive value in the iteration of 6, therefore in the 6th iteration our root is between 0.5625 and 0.59375, therefore equal button. We don't need to change the value of A, and we need to change the value of B, it is alpha C, and equal button, then we have 0.578125, and again equal button, then we have negative value minus 0.05262374878, and again equal button. In here, in the 7th iteration, our root is between 0.78125 and 0.9375, because here negative value, therefore we need to enter here 0.5782125, and for the B is same 0.59375, and here we have to click alpha and C, and don't need to change the value of B, and again click equal, and we have C 0.5859375, therefore we have the sign for the FP, this value. Here we have positive value, it is 0.01031398773. Here we have positive value, therefore in the 8th iteration our root is between 0.5782125 and 0.5859375, equal button, then we have to change the value of B. We have this value 0.58203125, again equal button, here negative value minus 0.02571600676. So finally we can say that for the two decimal places we have same digits, Therefore, this is our root. In this problem, to find the number of iterations, we have to use this inequality, which was gotten in the theory part. In this inequality, firstly we know that absolute value of Pn minus P represent the distance between root and midpoint, which is less than or equal to the b minus a over 2 to the power n. Then for a more accurate solution, the distance between root and midpoint should be very small. Then in the problem, precision is given, which should be 2 decimal places from the root. Therefore, we can write this inequality, and solving this part, number of iteration can be gotten. Then substitute the input values a minus 0 over 2 to the power n less than 10 to the power minus 2, taking the log for both sides. Then finally we have n greater than 7. N greater than 7. Therefore, number of iteration is more than 7. Continuing the process of bisection method, after 7 iteration, we can see same digits for 2 decimal places in the value. Therefore, we can get 0.58 as the answer.